Guys, I'm back with another video today. So today we are going to do another lead code problem. So we're going to do the 198 house robber problem. This problem's let's check this problem's tags right now. So it is dynamic programming. It's our first dynamic programming question, and it's my dynamic programming question, which is the first till now. I haven't done it till now, so it's my first question. So let's try solving it today. So we are a robber here, so we are planning to rob houses on a street, and then we have each house has some money stashed in it, so we can't rob two adjacent houses together. So that is the only constraint which is there, and then we have to find the maximum amount that we can rob without alerting the police, such that we don't break into two houses which are adjacent to one another. So let's try solving it now. So we are given an array here 1 2 3 1. So we can't if we go to 1 we can't rob 2. So if we choose 1 we must choose 3 or 1 again. So if we choose 1 and then 3 we get 4, or we can choose a 2 and then 1 which is lesser 3. So that's one way. Greedy approach won't work in this. It's pure dynamic programming question. So we can either use tabulation and memoization. We'll first start with a recursive approach, and then we'll try memoizing the answer, and then we'll reach the tabulated approach. So let's try understanding the question now. For example, let's consider one array like this. Wait a minute. Yeah, this array is present. So 2 7 9 3 and 1. So let's get our thoughts in such a way. We are a robber right now. We're going to steal stuff and try getting maximum money out of the robbery. So imagine we start from the first house. So first house we have a 2. So first house we would loot first house. Just imagine we looted the first house. We got like 2 rupees, and then afterwards we can't go to the first indexed house because it would alert the cops. So and then we would go for the next house to 9. So 9 plus 2 11, and then we have to go to 1. So here you see, you people may start thinking that it's only alternative elements, whichever alternate gives you the answer. So 2 9 and 1, and then 7 and 3. We would consider 2 9 and 1, which will give us a profit of 12 rupees, and then 7 plus 3, which will give us a 10 rupees profit. So we would find the maximum of both of them. So that would become like 12 rupees profit. So that is not the case always. So I've tried this approach that way, but it didn't work out because I found a negating condition. Just imagine there's a condition, there's a test case like this. Imagine there's a test case like this. Imagine it's let's consider 10 1. Okay, 10 2 2, and then 10. Imagine in this case I did the same thing. I went the robber went to first house. He got 10 bucks, and then afterwards he went for the alternate house too, and then gone. You got 12. Actually, you can do better way. You can like go to the 10th house, or you can go to the first house, get your 10 bucks, and then you can directly go to the last house and get your 10 bucks. You can get a maximum profit of 20 bucks. So that's the robber needs to think more in a more efficient manner. So we would use DP here. So and first we'll get a recursive solution for this question. So we'll understand the recursion tree first here. Right now, let's check it out. Okay, wait a minute. Yeah. So I was reading an article in GSG regarding tabulation versus memoization. So let's start with the memoization, which is a top-down approach. So imagine we are starting from the last here. So 1. Imagine so I'm going to tell this one thing. So if you go left of the tree, of the recursion tree, it's going to be that we took the house, like we robbed the house, and right is going to be if we didn't rob the house. For example, I went and robbed the fourth indexed house, so we got a profit of 1 rupee, and then I have two choices. If I didn't take 1 rupee, I didn't go to the fourth indexed house, I have a choice of going to the third indexed house. I can go here. It won't alert the cops because they didn't rob this house yet. And then if at all I took the first house, I can't take this third indexed house. I have to take the second indexed house, which has a profit of 9 rupees. So and then afterwards you got your afterwards we'll go to the left. Okay, We went for the second indexed house. Next we have two options. If we don't take the second indexed house, we can go to the first indexed house, which is at like 7 rupees you get. And then you have one more option. If you have taken the 9 rupees, then you must and should, you can only go to the 2 rupees house, the zero indexed house. You have no other option. So after that, you would after going to the last the bottom index, all you get is minus ones. There's no use of that. So and then the same thing goes to the right houses also. So I'll explain it from the bottom up approach as a tabulation memoization will try. So imagine you're starting, imagine you have a 2 here and then you have a 7 here. So here right is you're including the house, and left is you're not including the house. So right is you're not including the house and left is you're including the house. So you have two options here. You can either do 9 plus 2 or 0 plus 7. See, I'm telling 0 plus 7 because you're not including the 9. So it's going to be 9 plus 2, 11, or it's going to be 7. So 11 is largest, so you take 11 here. And then here, let's go to the right side of the tree. So here you see one thing we observe. So we have a 2 here. Here anything, both the times you get the same answer. Like you either get a 0 or you get a 2. So 2 is better, so you take 2 here. And 7, because you see, if you don't take 7 and if you take 2, it's like either 7 or 2. 7 is larger. And one more thing here you observe, you have a lot of repeating answers here. So repeating sub problems, that's why I use memoization here. So you see there's 7 rupees here and there's 9 rupees here. So then you would obviously go for the one like 7 plus 3 is how much? It's a 10. So 10 or 7 plus 3 is how much? Okay, yeah, wait, I'm forgetting right is included or not included. Okay, so 7 plus 3 is going to be a 10. So 7 plus 3 is going to be 10. I don't know why I wrote 11. It's my bad. I'm sorry. So and then we have a 9 plus 3 here, which is 11. So obviously we would include the 11 itself. Yeah, is it 11? No, it's going to be a 12. Sorry, this is 12. Oh my god, I did such a big blunder. Okay, so 11 or 12. 11 or 11, and then 11 plus 1 you get a 12. So that's the largest. I messed up the explanation here right now. I'll try coding it up, then you people will understand in a better manner. So let's start. So here we can check. Let's start with creating the help. Let's write the helper function itself. You would obviously one thing you observe here the index is changing. Here you see, here when you go to the left, you have to, if you're taking this number, the left is going to be index minus 1. If you're taking, it's going to be index minus 2. I'm sorry, left is index minus 2 and right is going to be index minus 1, and you're not going to include a 9. So let's try coding it up right now. So we have int, we have an array, and then we have, what else we have? We have the index. Index is going to start from the last to the last to first, and then I think only these two things are enough right now. Later when you're doing memoization, we'll take a array, which so that we can store all the values of the sub problems. Now the base condition is wherein imagine the index is equal to index is less than 0, then we should return a 0. That's the edge case. So if index is less than 0, then we would return 0, and then now we would have a left. We would have a costs of the left, like profits which you get from the left side. So from the left side, as I told you, it's going to be, left side is inclusion. I have told you again, I'm forgetting it myself, but let me try. So left side is inclusion. So if you're taking from the left, you're including the number itself. So you'll include this. So it's going to be a array and then index plus the helper and then the array obviously, and then the index minus 2. It's going to be a minus 2, and then the right you're not including it, so let's take 0 plus the helper and then the array and then index minus 1, and then we would return the max of these two. Okay, and now let me return the answer. The nums array, and then let's have the size. We are starting from n minus 1, the length minus 1. So let's check whether we're getting the right answer or wrong answer. Yeah, we got a 4. Let's try for this thing. The condition I told, the starting and ending. We should get a 20. Yeah, we got a 20. And if I try submitting it, we'll get a TLE because we didn't memorize the answer. See, we got a TLE. So here we would use an array. So let's see the problem, like what are the constraints, like sizes. So yeah, we need a maximum. We need to create an array of maximum size of 101 because he told it's going to be from 1 to 100. So integer of dp is equal to 101. We have created this. We'll change the arguments because we are passing the array also. dp and then index. Okay. I forgot, we have to initialize, we have to fill the array with default values. Arrays dot, I would fill it with a -1. Sorry, dp comma -1. So all the default values are -1 in our array, our memoized array. So now next step would be, yeah, we would change the arguments now. dp here and then dp here, and we would store the value here, like return dp of index, and if at all the dp's index value is not equal to 1, it's not equal to -1, then we would obviously return our let me zoom in a bit more, you guys can see properly. So I would return the index with the index value. So we don't need to do all these recursion calls and increase the recursion stack size and disrupt the memory. So let's just try right now. What do we get? Hope it's all right. Okay, let me zoom out again. So let me run the code. Hope we get the right answer. Yeah, we got the right answer. So I'll just change one test. Let's submit the code. This is for this memoized solution. Yeah, so memoized solution is kind of not so time efficient. So one of my subscribers asking me about explaining the time complexity. So I'll do the tabulation thing and then I'll explain about the time complexity of the solution. So normally we are getting this if it's a tabulation solution, then it's going to be big O of n, and then space is going to be constant, it's going to be a n. So let's try the linear solution, and which is the more efficient solution. Let me clear this whole code again and let's try submitting once more right now. So I would as you guys know what a tabulated solution is, so it's going to be a bottom-up approach tabulation. So that's what we're going to do here. So we would create one more we would create the array here. It's going to be 101 size. New int. So our next step would be, we'll just I'll have the length. I'll start from 1 and then go all the way to n, and here and as you can see, you know what left side is. So so we'll have two variables, take and not take. So take and then not take, these two are the variables we have. So if the I meant, so I is 1 right now. So imagine I have something like, if I minus 2, if I minus 2 equals to 1 minus 1, we have to handle that separately. So if I minus 2 is equal to minus 1, then take is going to be, so we are taking the value, so we will include it. So nums of I value, and then dp, so here we are storing the value, so dp of I minus 2. Sorry, we are not including dp of I minus 2 because here wait a minute, because the value doesn't exist, like minus 1. So I'll write the condition for that. So take is going to be at wait a minute, I messed up. Okay, take is going to be a nums of I, that's it. Oh, sorry. So take is going to be nums of I and then plus the dp of I minus 2. So if it is not minus 1, like if the I value is 2, then obviously we would take it. So and then I forgot to initialize the dp value, initial value. Dp of 0 is nothing but the initial value of the nums, and after that we would take the not take also. The not take is going to be, if you're not taking the value, it's going to be 0 plus dp of I minus 1. So and then dp of I is going to be the max of take and then not take. Hope it makes sense. In the ending I would return the dp of the n value minus 1. I would return it as the answer because there will be errors. Let's see. Yeah, we got the right answer. Let me try for this. Yeah, that's fine. So this is a more efficient solution. I think normally when anybody's trying to understand a DP question, it's better to start with the memorization, like get a recursive solution in mind and then draw the recursion tree and then understand how you can store all these sub problems in a memory location in a data structure, and then afterwards you get a intuition of making a tabulated solution. So I think that's the way to do it. That's how I found the way to do it, this question. So I'm going to submit this. Yeah, see, it's more efficient because tabulation does not have any recursion stacks. It doesn't use any recursion stacks, and it's more efficient because we calculate the sub problem for a only given solution. So this is going to be time complexity O of n, and then space is also constant because we are using a n size. It's not constant, it's going to be a size of n, so it's big O of n. So I hope you people understood it. Understand the recursion tree, and then if you understand the recursion tree, then you can easily approach a DP problem. It all starts with recursion. Thank you very much. Please subscribe.